change the seat. I'll point out, hey, you get up from the seat and go to that seat. Alright, so what I'm actually doing, I'm pointing out that you get up from that seat and go to another seat. Alright, so I pointed out. So if I am the microprocessor, I want to access one memory location, I'm pointing out. Now what is accessing? Either to get data or to place data. If you want to take data from that memory location, you are pointing out that I need data from that location. If I want to put data, I'll be saying go sit there, or I'll be saying go save there. So in both of the cases, when the data is being fetched or placed, stored back in the memory, the MAR is always pointing out. Remember. So that is why we don't need the address to come back. Address is always pointed out. Okay. Now, how does this 50 reached out to the program counter? That is another bus. That is called control bus. What do we call it? Control bus. So control bus is actually not just for PC. It is actually responsible for other signals as well. Okay? So we will discuss about it later. So through control bus, the address of first instruction has reached out to PC. From PC, it goes to MAR. From MAR, it goes out to RAM as an address. Now, from that address, data or the instruction at that address arrives in MDR. So now it is MDR. MDR. Memory data register. MDR. Few of the books and websites also refer to it as MBR, memory buffer register. We'll talk about buffer later, but in short, buffer is the area where we keep the data until it is get utilized. Once it is get utilized, buffer is then used for another data. So that is actually what is happening with MBR. So sometimes it is called memory buffer register, BR. But that doesn't make any difference as far as the purpose of this MDR is concerned. Alright, so now what MDR is holding? MDR is now holding LDD, what? 56. LDD 56. This is now the content of what? MDR. Now you need to understand that this content is actually arriving from the memory. Do not think that it is arriving from the data part only. MDR is having the data from the address mentioned in MAR. Okay, so the bus, the wire that is being used to send the data is called data bus. Alright, what do we call it? Data bus. Okay, so it is not bringing from the part which is actually the data part. It is bringing from the part of the memory whose location is mentioned in MAR. Now there is a general confusion. People do write like from MAR it goes to MDR. Nothing from MAR goes to MDR with it. MAR points to that memory location, and from that memory location you might have either the data or the instruction. Whatever it is, whether the data or the instruction, that will arrive in MDR. That is the case. You need to mind it. Nothing goes from MAR to MDR directly. Rather what basically happens that MAR points to a memory location, whatever the content at that memory location. We know that either we have the data or the instruction at any given memory location. From that memory location, whether it is data or instruction, that arrives in MDR. In this case, we are specifically talking about instruction. Do not think that this bus is actually going to this address or this bus is actually going to this address. These buses are going to the memory. That's it. Not to a particular address. Whatever the address that you put on that bus, the data will arrive in MDR from data using data bus from that particular location. So this is actually just for your understanding that it is pointing to it, it's bringing back, but do not think that it is actually physically going to that particular location. So get the idea? So from the MAR holds address 50, that address 50 holds LDD 56, that is actually arrived in MDR. Do not think that these are two parts. This is the whole memory. This is the whole memory. Okay? I just made these two parts distinct just to make you feel that these are instruction and this is data, but we know that in memory anything can be at any location. So when MDR has got the instruction whose address was in MAR, that instruction from there now goes to another register which is called CIR. CIR. So what basically happens that the content of MDR, if it is instruction, it goes to CIR, and that CIR has now LDD56. What does it have? LDD56. Why does it have LDD56? Because from MDR it goes to CIR. It's a common behavior. Do not think that there would be anything else other than this. No, it's a common behavior. As soon as PC has got something, PC will deliver it to MAR. As soon as MAR has something, that will be placed on the bus. As soon as that address will be placed on the bus will actually go to memory and will say that deliver the content of this address. And then computer would take the content of that address, in this case it is instruction, and place that over the data bus. As soon as that data bus has got something on it, that will be delivered to MDR. And MDR, if it is instruction, that goes to CIR. That is a common behavior. Now, CIR, current. Oh, we forgot to write the instruction. Memory data register definition. So it holds instruction at address in MAR. So whatever the address that is in MAR, the instruction at that address will arrive in memory data register. And then we have got current instruction register, CIR. So what CIR does? CIR is actually current instruction registers. It decodes and executes the current instruction. It decodes and executes the current instruction. Decode and executes current instruction. You have to write current instruction, right? It decodes and executes current instruction. So the cycle is now completed. Once this happens, CIR decodes and executes again from PC. As soon as that is done, again from PC, 51 will arrive in MAR. PC will become 52. MAR now points to 51. Add 57 will arrive in MDR. From MDR it goes to CIR. Add 57 will be decoded and executed. Now what is decodation? Decodation is like I said, let's say, my dear student, you bring me some water. Alright. So you saw that I'm pointing at you. You will then decode what you need to do to bring me water. So all that understanding and execution plan that comes to your mind, that how would I go, how will I open the glass door and I'll get out and reach out to that place where the water is, and then from that place you will fill the glass up and get back to me to bring me water. So that whole thing that comes to your mind, and then you execute it. So decodation is actually making a sense of the instruction and how that instruction will be executed, and then execution. Fortunately, all you have to write is it decodes and executes. That's about it. You don't have to, neither here in AS or not in A2, that how the decodation and execution happens. No. All you have to remember is just this cycle. From PC, the address of next instruction goes to MAR. As soon as it reaches MAR, it becomes the address of current instruction. PC increments itself by 1 in order to have always the next instruction address. MAR then points out to memory with the address in it through address bus. From that particular address, the content, which is the instruction that arrives in MDR, from MDR using data bus. And from MDR it goes to PC, where the PC decodes and executes it. It is called fetch, decode and execute cycle. What do we call it? Fetch, decode and execute cycle. Now the part from PC to MAR to MDR, it is called fetch. So if somebody asks you what is fetch, you would say that address of next instruction from PC goes to MAR. MAR then points out to memory, and from memory that instruction arrives in MDR. And from MDR it goes to CIR. That is fetch. And then CIR decodes and executes it. But there is a little more part attached to it. We will discuss about it. So now let's complete the microprocessor first. So what basically happens, that this PC and CIR are part of control unit. They are now part of control unit. So what is control unit? Control unit is basically is something that reads an instruction from the memory. The address of the location where the instruction can be found is stored in program count. Okay, this instruction is then interpreted. During the process, signals are generated along the control bus to tell other components in the computer what to do. The control unit ensures synchronization of data flow and program instruction throughout the computer. So what you come across few things. Number one, that this control unit is responsible for the fetch, decode and execute cycle. by having the address of the next instruction which will be executed. Okay, by having the address of next instruction will be executed, and then at the end, decodation and execution. Not just that, while the whole cycle is working, the execution, the order, the synchronization of the cycle and the parts in the microprocessor responsible for that cycle is also the duty of control unit. So it does synchronization. What is synchronization? Synchronization is that when a team is working, every member knows that from where to get the data and where to deliver the data and at what time. That is synchronization. So PC to MAR, then MDR, then CIR, that is synchronization. They work in order. Order requires some sort of timing. Alright, so that order is also maintained by control unit. And then control unit has got this bus attached to it called what? Control bus. The instruction is then at the end is executed. Signals are generated along the control bus to tell other components in the computer what to do, because control unit is asking everything inside and outside the microprocessor, especially inside the microprocessor, through the control bus use. Alright, so this was control bus. Sorry, control unit. Now, there is another part which is called ALU, Arithmetic and Logic Unit. ALU, Arithmetic and Logic Unit. Arithmetic and Logic Unit is supposed to be the hand of microprocessor. So whatever it does, the microprocessor, that actually the action part of it is basically happening using ALU. What does it mean? It means that control unit, like I am teaching you and I am writing everything using my hands. I am fetching everything. If I am having any work to do, I will do actually using my hands. So that hands to microprocessor is ALU. So anything which is logical or physical or whatever, that is actually ALU. We will talk about it later. So microprocessor's hand is what? ALU. Unfortunately, there is just one hand, so the speed is slow. But ALU is actually the hand of microprocessor. So ALU allows required arithmetic and logic operations. What are arithmetic operations? Addition, subtraction, division, multiplication. And what are logic? If, then, else, and application of and, or, not, nor, exclusive, or gates. That is logic. Alright, so if you have a statement if, then, else, then that means that logic part of ALU is actually dealing with it. And if you have got plus, minus, subtract, multiply, whatever, those all arithmetic operations are being done by the arithmetic part of the ALU. So while the program is running, this ALU is handling if, then, else, logic part, and addition, subtraction, division, the arithmetic part. It is possible for a computer to have more than one ALUs. You know, GPUs, the cards which are responsible for good gaming, right? Gaming cards, VGA cards, GPUs, graphic cards like GeForce, NVIDIA, and all. They are actually having more than one ALUs. We will discuss about it in detail later in AJUs. So it is possible for a computer to have more than one ALU. All right. So get the idea what is ALU? ALU is supposed to be the hand of microprocessor. It does all the arithmetic and the logic when a program is being executed. So, and it is also possible that one computer may have more than one ALU. Over here, when the ALU is actually working, the data is being generated. See, if I ask you that what is the result of 1 plus 2 plus 3 plus 4 plus 5, you might say, sir, 15. This is actually very easy for you because your brain is actually quantum. Quantum means it can do several things together at the same time. You do quantum computing. Whereas this computer is what? Sequential computer. I just told you that it does everything in sequence. It cannot do it quantumly. Your brain does it quantumly. So in sequence, it means that 1 plus 2, 3. 3 plus 3, 6. 6 plus 4, 10. 10 plus 5, 15. That is how computer does it. But you need to pay attention. 1, it should be kept somewhere in memory. Plus 2, 3. It should be kept somewhere in memory. Plus 3, 6. That 6 needs to be placed somewhere in the memory. And 6 plus 4, 10. The 10 needs to be placed somewhere in the memory. And then that 10 plus 5 is 15. So you need to understand that ALU, when it works, it requires a little memory every time, because if it does not have that memory, how it actually go on with additions. So for that reason, ALU has got accumulator. Accumulator is actually a register which is used by ALU to keep the data. I call that data interim data, the data which is being produced during the execution in time, and the data which is at the end is produced. So what is accumulator? Unlike other registers which are special purpose. Special purpose means they only do whatever they are asked, whatever they are actually built to do. Alright. Whereas the accumulator is temporary register and it is used when carrying out ALU calculations. So it is a general purpose register. Rest of the registers that you have studied were actually special purpose. So these were special purpose. Alright, from here until here, these were special purpose. Whereas this accumulator is general purpose. General purpose register, general purpose temporary register, temporary usage register, that can be used by us as programmers, temporary in nature. Alright, so that can be used by us programmers, by other microprocessors, whatever it is, accumulator, which is inside ALU, and it is being used by the ALU for the calculations during the execution of the program. So this is ALU now, which is having accumulator in it. Now, who is actually controlling this ALU? Obviously, there is one thing that controls this ALU, and that is control unit. So ALU is asked to do something by control unit, and the result goes to control unit as well. Okay, so the result goes back to control unit as well. And this accumulator and ALU, they are part of it. So ALU is actually controlling accumulator. All right. Now, this accumulator is having a link to arithmetic and logic unit, and then it has got another link to this accumulator to MDR. Now why? When the whole calculation is done, the result is found, the result is placed in accumulator, from where it will go out to memory. Until unless it is in memory RAM, we cannot access it. Whatever that is happening inside ALU is inside ALU. ALU itself is inside microprocessor. So we cannot access ALU or accumulator directly. So what computer does when it finds the result, it places the result in accumulator, and from accumulator it goes to MDR, and from MDR it goes out. You can see that this data bus is actually two-way. It is bringing in the data from the RAM, but it takes the data out from the RAM as well. So this is two-sided, but not two-way. This is single-way, two-sided. It is that alley which is in front of your home, and there is just one road. So if two cars are coming, one has to get aside to find the way for another car to get out of that choke. So get the idea. So it is actually a single way where the data is coming in and going out as well. All right. And when the instruction arrives, it goes to CIR, but when the data arrives, it goes to accumulator. If the data is arrived, that goes to accumulator, which is being consumed for the next instruction or the current instructions work. All right. But sometimes the data is also required by CIR. So how would CIR access that data? That data will go to accumulator, and from accumulator, ALU will deliver it to CIR to work with it. All right. So get the idea. So this accumulator is directly connected to MDR so that the data could be delivered.